Hi guys, we are group 2. For today's discussion, we are going to explain about how CBC works and its properties.
Okay, this is CBC, the most widely used approach to encrypt a large message. So it stands for Cipher blockchaining. Okay, so in CBC, the input to the encryption algorithm is the result of XORing the previous ciphertext block and the current plaintext block. Okay, to encrypt the first plaintext block, we use a so-called IV. It stands for initialization vector, and we XOR the IV with the plaintext block and give the input to the encryption process to produce the first ciphertext block. And then the first ciphertext block is used to XOR with the second plaintext block as input to the encryption process. Okay, to produce the second ciphertext block and so on so forth. Again, the CBC, the current ciphertext block depend not only the current plaintext block but also the previous ciphertext block, which in turn depend on not only the previous plaintext block but also the ciphertext block prior to that. In other words, in analysis, it is very hard to figure the plaintext block just looking at the current ciphertext block. Okay, more importantly, if two plaintext blocks are exactly the same, meaning that they are repeating the same message or in two different messages, their ciphertext blocks are not likely to be the same. Okay, in addition, if an attacker attempt to swap in a different ciphertext block or rearrange the order of the ciphertext blocks, the ciphertext is not going to decrypt properly into the plaintext.
Okay, thank you to my friend Azai. So I will continue to implementation of the CBC. So CBC is a AES block cipher mode that trumps the ECB mode in hiding away patterns in the plaintext. CBC mode achieves this by XORing the first plaintext block with an initialization vector before encrypting it. CBC also involve block chaining, as every subsequent plaintext block is XORed with the ciphertext of the previous block. So, how the mode of operation is suitable for block cipher or stream cipher? Basically, block cipher encrypt data in fixed size block. So, block cipher are designed to encrypt a single fixed size with a chunk of data, which present issues for plain text that are not exactly the correct length. So padding helps to solve the issue of the undersized plaintext, while block cipher modes of operation handle ones that span multiple blocks. Meanwhile, for the stream cipher, generates a stream of bits that are in exclusive OR with the plaintext to produce the ciphertext. Thank you.
Alright, so thanks to Hafiz for the briefing on implementation of CBC. My name is Chen and I will be talking about the properties of cipher block chaining. So there are four properties. For the first one is identical plaintext. So changing the initialization vector or the first plaintext block during the encryption will produce different ciphertext with same plaintext because CBC is very sensitive with its block. So it leads to the implementation will be more slower as you compare to ECB mode due to its complexity. So for the second property is chaining dependencies. So the information from one plaintext symbol is diffused into several ciphertext symbols, which improve the complexity of encryption. So it actually leads to a better security when you have different blocks for encryption. So conversely, it leads to a slower operation for large scale or any bigger encryption or decryption. So the larger the encryption, the longer the time taken for operation. So for the third property is error propagation. So it has the immunity to tampering since it is difficult to insert symbols during the encryption, right? So even if you modify the ciphertext, it might lead to the corruption. So a bit error in a cipher block affect the decryption of all subsequent blocks. So for the last properties is about efficiency. So CBC has better security because of subsequence using plaintext block by repeating the ciphertext block to encrypt it. So it repeat the blocks until it finish all the encryption. So the parallel CBC encryption is not available because a ciphertext for a block is necessary, meaning that the operation cannot be parallelized. So I think that's all from us. So thank you guys for listening.